Now, I just told you that we have the reaction of O2 and H2 going to H2O, and I made the comment to you that it proceeds through a series of intermediate reaction steps. Now, why do these steps exist? Well, these steps represent individual changes from reactants to products, each separated by what's called a transition state. So a transition state is a high energy intermediate between reactants and products. And for a single reaction mechanism, there's only one transition state. So we have the reactants, they have to gain some energy, react, and then they go back down in energy, and that high peak is what's called the transition state. So we had two mechanisms in the previous video, O2 going to 2O, and H2 plus O going to H2O. So if we represent this as energy versus time, meaning that we have 2H2O2 here, and ultimately we're going to produce 2H2O, we're going to go through two transition states because we have two intermediates. Now, schematically, what's happening is that as we go along this first peak, we have oxygen associating. So this is our first reaction, 1. The height energy between the reactants and the highest energy intermediates is what's called the activation barrier. Or EA. Now this is basically how much energy has to be absorbed by the reactants to basically begin to start the reaction before we get dissociation down to H2 and O2. Our second reaction is going to do the same thing. We've got some energy associated with breaking H2 apart to give us H2O. So we're going to have a second activation barrier here. So as reactions proceed, they typically proceed through several transition states. Now the only exception to this is what's called an elementary step. Elementary step only has reactants going to products through one transition state. We'll do another video where there's a lot more about the importance of elementary reactions. But typically, most reactions are composed of several transition states. And so we're going to do a few videos here on how to figure out activation barriers based on graphical analysis, as well as how to do it through experimental results.